This meeting is being recorded.
All right. Daniel, want to?
Yeah, of course I can start. So I can start with a short presentation, like giving a short overview of why we are here and basically this history of VSSo and how we got there. Let me share my screen. Perfect. Can you see it?
Yes.
Okay, so what you see on the screen is basically VSS, the Vehicle Signals Specification. I think like most of the people here in the call are aware of it. What is a specification? It's basically a taxonomy for vehicle attributes, sensors, and actuators. It's a tree-like structure. It has some few components. One is branches, what you see here in blue. It's basically it's there to sort the signals and to give a structure, like which is related to the structure of the vehicle. And then in the leaves, which are red here, you can see basically the leaves which contain the data at the end. Down here, you see an example, like it's always dot notation. You will find it there, which is basically the path through the tree. There you can see metadata, like which type it is. It can be sensor, actuator, or attribute. The data type is there, the unit is there, and the description. So all that is defined in YAML. YAML was chosen at the beginning because it's really easy to understand and to read and to extend. So that gave the specification, I think, as well some popularity. On top of this YAML specification, we have a tool set which is able to serialize the YAML specification to different formats. We have JSON, CSV, we have GraphQL, and so on. So the tooling is evolving all the time. So this is basically right now where we are at, and the specification as well. We meet every week, and basically this is the basis for the ontology. Because we were thinking, why do we need an ontology? We were thinking that as long as you stay in the domain of vehicles, it's absolutely fine to share the data in such a format. As said, we see GraphQL down there, but as soon as you step out of it and want to relate it to other domains, we need a more formal way of describing it, and there is where the work on the ontology started. So, giving you a bit of a history, VSS, the work started on VSS even before my time in 2016. I think the structure of VSS was at the time quite different. So we had basically a subtree for attributes of signals, and but we found it as one of the few compelling standards, which first of all is independent of the underlying protocol, and second of all is open and extensible. So when we saw it, we thought already like, oh, like that's basically the perfect basis because of the two reasons to start the developing and of the ontology on top of it. So the initial VSSo version 1 was based on this version with attributes and signals as subtrees, and was done by Benjamin Klotz. He was a PhD student at that time at BMW, and we were working together in the team. So this is basically the first version of VSSo, which you might have seen as a member submission as well in the repository of the W3C. Like during the work on mapping VSS to VSSo, we saw quite some designs in the original VSS where we would think it would be easier to change if we want to basically have both side by side, basically the taxonomy and the ontology on top. So a lot of work which Benjamin did in the development of VSSo basically came into the got into the version 2.0, which was released last year. So as said before, the first version of VSSo was received as a member submission at the end of 2020, and the business group started working on it. And there's as well where Felix and me met, and where we started to like work on the next version of VSSo. So last year we made a first proposal. Then it was listed as a deliverable of the on the W3C recommendation track for the automotive working group recharger, and then now since I think a week, it's now the first public working draft released in the W3C. But what are we talking about? So first we were thinking, okay, like what use cases we want to cover. So there, like, and why do we need the ontology? So there are two aspects. One is analytics. So the one is like, which it should comply to, is like to receive current vehicle data. So like the normal, let's say, digital twin kind of things where you have like a backend application and you question or like you ask for the vehicle, like the static and dynamic properties of the vehicle to get the current state of the vehicle. The other one is like it should comply to vehicle data over time and for analytics use cases. So there's basically the combination of established standards like SS and SOSA and like VSSo should be a domain ontology for it. And the third one is like for services, and let's say that you want to retrieve or change vehicle data. So there's basically where it could be like a domain ontology for the Web of Things. So these were basically the three use case clusters we came up with and we discussed initially. So the current status is what you see here. But first of all, I just ask for your attention on the right side here, the different circles. So basically, as said, it should come together, be really close to VSS. What we don't want is that we have like that they diverge pretty quickly. So that's why we want to have a tight coupling. So what we first did was defining a VSSo core ontology that you see as well in the delivery of the first draft. The core ontology basically covers the basic concepts of VSS. You see what is called in VSS branches here, vehicle component, and so on. You find on the left side, you find the basic concepts back you see in VSS. On top of that core ontology, we created a tooling which basically generates concepts on top of the core ontology. So basically everything which is defined in VSS should find its equivalent in the VSSo ontology. And on top, and there maybe if you have time later, Daniel can say a couple of words. It's basically the link to other ontology to form more use cases. We had like before the observations, it can be streaming, and like where VSSo can be then like a core ontology that could be extension to the original ontology. So we have three things. First, VSSo core ontology with the basic concepts taken from VSS. The second one is the generated concepts taken out of VSS on top of this core ontology, and the third one is like possible extensions for other use cases like streaming or observations. So that in a nutshell. Here you see the basically the or like the current state of the ontology. We can jump into the documentation later, and that's basically why we are here today to discuss. So like there were some issues we had in the VSSo repository, and what we want to do here today is like after maybe now having some initial questions answered, to jump into the topics and discuss how we go on. Like one is like how the generated concept, for example, if they should subclasses or instances and so on. So we have a couple of issues open we want to discuss, but I want to give you the chance to answer to ask some questions and to start the discussion.
Thank you, Daniel. Maybe a little too fast for some, but well, yeah, don't worry, it's all good. Any questions, comments, things that people are want to sort of learn a bit more about? That was very quick and very good high level as far as history and how things are structured and the sort of advancement onto the standards tracking process. Anyone?
Yeah, first, hey, this is Ravi Chalanti. I'm part of Ford Motor Company. First of all, this is a good initiative, good proceedings, good approach that you have started off with. I have certain questions and then inputs. The question is coming from outside, that linking to other ontologies. Which are all the other ontologies that are happening? What all are the other ontologies?
Right now, the design is pretty close to SS and SOSA for observation. So that was was a driver for some of the major design decisions. And the other one is IoT Stream. There's as well Danielle here who can help you with that. But these were the first things we were thinking about.
Yeah. I mean, to add to that, the good thing is that once we are at the level of the semantic web of RDF, I mean, there is no limit. You can link it to any kind of ontology. So if you have your own ontologies, for example, you could link them to the VSS ontology, or you can use existing ones that are out there. If you go to link data or schema.org, you will find plenty of already existing ontologies. I think that's the power of the semantic approach, that you can basically link it to whatever you want. At least we at Bosch find this a very, very powerful approach.
Yeah. I definitely understand that. It's a very good approach. Just wanted to understand like what is already started. So just those two standards, SSN and SOSA, are like in progress as like an ontology approach, right?
Maybe I can complement here just to double the previous comment. Is like what you see here on the right side, the core ontology and the generated concepts, they are intended to be aligned to the base foundation, which is the vehicle signal specification. And on top of that, you might decide to extend it with your custom ontology or with other ontologies. And that is the idea, to keep the core and the generated concepts aligned, and then you can build anything else on top.
Okay, sounds good. Now the input is the VSS Core Ontology, the VSS signal specification is primarily on the attributes and sensors and certain data from IO devices. But I feel like there is more to it rather than just like sensors and actuators. There might be other combination of devices that can come in the future. If you have certain like sensor fusions that is happening, for example, camera and LiDAR together, especially from the autonomous domain, the kind of data that we want to have. Even though it is not part of the VSS, the signal specification, it can be captured as part of an ontology. Like the different kinds of data that you want to have for an individual sensor versus a combination of sensors, like a multi-sensor data. How is that coming up in the current specification? I do not know, but if we are just going to align with VSS as an ontology, maybe that is not sufficient. This is just my perspective. We might have to be a little flexible on alignment with VSS data.
May I think it's a really good point, and that's as well maybe couldn't kick off the discussions right now. Another area is, for example, the vehicle components, no, which are definitely underrepresented, as said before. Like as a in VSS, it's mostly basically structural element. But if you think of bill of material or those industry use cases, no, like they are like not really represented correctly through VSS, no, and those are the things like as you said, like camera and sensor fusion there as well. Those are the things we have to think about how to align it. Like what should be part as an extension, for example, like how that you take, for example, a VSSo core vehicle component, and then extend it maybe with the knowledge you have from the different domain now for the industry use case, or like incorporate it directly into the ontology. That's something where I would be really happy to start the discussion on.
Okay, great. Yeah, if you're considering that, that's very good. Like maybe we can call it out as a wish list and plan for it to include later.
Sure.
Yeah.
I mean, that's, I mean, this, we can do it either in the working group and in the W3C, and I'm pretty sure, I mean, this is a starting point with the signals, but there is, of course, much more to a vehicle that you can probably also describe in an ontology. Just to give you some things, what we, for example, do at Bosch. So we use this internally, and we align then, of course, our ontologies. I think that's the key if you want to get the most out of this technology. Is you can start small at individual areas, but then you have to see, I mean, which concepts in the different ontologies are the same, and which ones are not the same. So, but the same ones you should then unify and link together. Then you arrive at a, let's say you have then a collection of ontologies that describe whatever you want to describe in your domain. Could be a vehicle, could be something else, depends on your company. And that's really a powerful approach. And so far it scales very well because you can start in these individual domains and build it step by step. Yeah.
Thank you, Felix. So you already have things in practice at your organization that you're aligning with the VSS and the core information.
Yep.
Okay, so that comes to a continued second question from me is, when we are aligning all this information, the VSS signal specification has a certain definition of a given keyword. Let's say what you call a temperature sensor, or what do you call as a door, and what do you call as a cabin door versus an enclosure like a backend kind of stuff. Where is this standard definition taken from?
You mean in where how we come up in VSS with those name and the
names and definitions? The naming conventions like camel case or like dot based notations, that is like clear, but like why should I define cabin door as a door, a compartment, or an enclosure for passenger access? Why should it not be called as just access? Why should I put the word passenger in there? The literals.
You mean already in the specific, like do you refer already to this
the
document?
VSS?
Or?
Yeah, let's go to one any parameter. I'm sorry, I think it's in let's say bank one temperature. Maybe I need some translation there. I'm sorry.
So, no. That's the point. I just want.
Excellent. This is a very good example. So at the left bottom, you have this YAML specification. The vehicle speed as measured by the drivetrain. That's the description, correct?
Yep.
Where did we get that description from?
Okay. That's a good question. That's so basically, as said, in VSS, it's it's like actually not really taxonomy, as it's like at the end, it's a part of relation always between, and those those branches, as we call it, as you see here, cabin or seat or like drivetrain, chassis, axle, and so on, they are basically logical sorting, no, like reflecting the structure of the vehicle. It's like in like it came up with discussions and like in like proposals, and then we discuss it in the VSS meetings. But it's not, and there it's like when we jump into the ontology, it's really then as well the question where you put your signal and how you define the relations. Oh, like in VSSo, we left it open so that you can connect it straight to the vehicle, like or to a component. But we wanted to keep the structure. No, but in some use cases it doesn't necessarily make sense to have the strict relation between a specific branch and its signal, no, like in VSS, because it's not what was thought in VSS. In VSS, it's just a structural element.
Yeah, but to give you an example, I mean, it really depends on which vehicle speed you are talking about. Here in
Exactly.
this case, it's the drivetrain speed, and this can be a different vehicle speed than the vehicle speed you measure at the wheel, for example.
Perfect.
First of all, it's a different
Thank you, Felix.
accuracy or something like that. So in this sense, I think it really makes sense to have this differentiation, because then you can say, for example, you want to develop a vehicle application that uses the signals, and this application needs to know, do I use the wheel speed, which could be okay for some use cases, or do I use the vehicle speed measured by the infotainment system via GPS, or do I use the drivetrain vehicle speed measured by, I don't know, which electronic control unit inside the drivetrain. So this really is a difference. Yeah.
Definitely,
Yeah.
there's a difference. What I wanted to say is that you have the flexibility that then to connect it maybe to a different vehicle
Sure.
component in VSSo,
Sure.
if you like to. No, like you have the that's what I wanted to say. You have basically an observable signal, and you can connect it then in your ontology if it fits as well to a different ECU, which is maybe then a vehicle component than suggested in VSS. I just want to say that there's like in VSS the meaning is a bit different than at the end in VSSo. So.
Yeah.
So that was my question. So the description here is come from W3C, is that right?
This one here, what you see is from Covesa in close collaboration with the WCC.
With everybody.
And from there exactly. And from there we generate basically the VSSo.
Okay.
Ontology.
So if we come to that other slide, the one which you're sharing, where about alignment with the core ontology, here, when we define our data elements and attributes, the definitions, are we aligning with what is already there in VSS Core, or do we have a chance to modify that? Like an ontological definition where it can be less ambiguous to at least majority of the teams. And let me give an example
You
in
have
that
a
case.
specific example.
Yeah, exactly. I got your point. So let's say I'm talking about cruise control system. I have a set speed. So the definition of set speed can be, if you search in Wikipedia or in, just search for search engines, it will give you a different parameter. If you go to SAE, Society of Automotive Engineers, they might have a definition for that. If you go to IEEE, they have a different association or different definition. So if we, as a team, say that we will use, I don't know, SAE as a standard, then you go to their database and search for acronyms and definitions of that vehicle speed word, and then pull it out and say like, this is the best definition for vehicle speed, and we capture it in ontology.
What we can do is, I mean, you can have multiple definitions linked to the same ontology element. So we could carry over the VSS definition as it comes from Covesa, but you can certainly also add other definitions and can say, okay, in SAE this is defined as, I don't know, different description for the same element. And then you can see how the different definitions relate to each other. it's difficult to, yeah, I don't know. I mean, that's something that we could do, or we agree all on on one common source for the definitions, but very often they don't have then the definitions for all the terms, so it's really difficult in that regard to choose one of these.
Yeah, that's what I just want to understand the plan, because the generated concepts, like generate the data definitions from VSS, is based upon the core ontology. So the core ontology has to be as less ambiguous as possible for majority. So when you say vehicle speed, you should not say that it is, you know, drivetrain, because even within drivetrain there are multiple sensors that provide you vehicle speed.
No, I think you meant like not the core ontology, but the concepts that are populating the core ontology. So the core ontology is basically a simple mapping,
Correct.
where you take branches, and those branches are the vehicle components, and the leaves of the tree that you saw is the actual name for accessing the data, what in VSSo would be a property. So if I imagine that you want to use a signal or an attribute or a property from a vehicle that is not described in VSS. Is that correct?
That is correct.
Yeah. So in that case, I think your question is more towards how do you make use of this ontology if the concept is not available in VSS. So then I would recommend that if you have a specific use case for that, you can suggest the inclusion of this property in VSS and then just regenerate the VSSo that is automatically done.
Yeah,
Well, then maybe I
if
should.
or if you are not okay with the definition of a VSS property, I mean, for example, you can in the Covesa VSS, you can ask for a pull request.
Okay.
So we looked also into this, and from the Bosch side, we added some VSS signals that we thought that are missing still in the specification, or we said, okay, no, we don't agree on that definition, and then of course it's a short discussion on VSS, but if everybody agrees, then it will be also changed. And this is, I think, this collaborative working by different companies on these standards is really what's key to improve the standard and move it forward.
Yeah, I could.
And maybe one word why we like. I mean, we have always a discussion. What is the single point of truth? No? Like we started and we said already. Like sometimes it's difficult. No, but on the other hand, it's like with VSS we reach a lot of people who don't have anything to do with ontologies or like with formal data definitions, and often you reach it's hard to reach those people who really want to directly solve some problems, and like in an application, or like having something like in an interface where you have to name things, no, like, or like sending in a small script data to the backend from the vehicle. That's where you basically like those people you can really reach really easily with VSS, because it's understandable. No, you have the YAML, you can create your serialization out of it, and it works well. No, like, and using that power as well to then boost the ontology. And here you see the core ontologies. I don't know, like if the naming or like if the difference was clear in the presentation. So basically here you have like really broad concepts, like the vehicle property, like it can be static or dynamic, and so on. So we have like here like really generic concept in the core ontology, like, and then this is basically the VSSo is then like generated out of VSS. So the core ontology is not that it includes the speed you saw before, but it's more like the generic concepts which are defined, like the structural concepts of VSS. So that's what it's in the core ontology. So it's easy as well then to extend if you don't want to use VSS, even though we recommend.
Yeah, I will just put a message on the chat window for everybody to, just take a look and try to tell like where I am coming from. Give me 1 second. Yep, I pasted that content on the chat. So in some of the documents that I've been going through, maybe if the teams have access to SAE, they can see that the definition of the coolant inlet pressure as per this is, it's a lengthy statement, but you can read that. So they try to reduce the ambiguity and really go into the actual engineering terms about what you mean by coolant pressure. Now, if you're trying to associate a device that can provide this information, you append it with saying like it is a device which represents this information using pascals or kilopascals or the corresponding units. And if it is temperature, you can say it can be temperature sensor device. It says like this is a temperature sensor device which provides the bulk coolant temperature entering the inlet of the manifold and inlet manifold of the cooler, and then it can be measured in like degrees Celsius or degrees Fahrenheit. And it is only a positive value. It cannot be negative, or it can be a negative value. Then this is the range it is possible to take. Those kind of things go as a definition of an ontological property where the other consumers or instances of this ontology can benefit more. They can tailor like what they want to do with this data. Let's say I'm trying to utilize this data for SI system, then I would use all my definitions in SI system or in metric system separately. So that is a generated ontology. I'm trying to give details of my use case to. So the intent is defining the term. That is part of ontology. Providing additional comments, annotations, labels, synonyms is also part of definition of our ontology, which is not present in VSS.
Yeah. I mean, as I said, I don't see any blockade. Like there are different ways to do it. One is like to extend VSS through that, and there's
Right.
of course always licensing issues. You have to
exactly. The request is like, can we enhance
and,
VSS? Because when I read the statement, like it has to align with VSS. When we generate it, there are some parts of it, Daniel, I feel they should go into the ontology rather than staying out of VSS core ontology and say that this is part of a generated ontology, not the core ontology.
I mean, what we have, Daniel, if I'm not mistaken, is the physical unit. I think this is defined, and also like this min and max values or things like that. So you have additional means to further specify like ranges or physical units of your property. When it comes to this exact definition, I mean, you could simply add this SAE definition. I mean, even if it's not part of Vss Core, you could add this. And that's also, I think, the beauty of the semantic approach, that you can really extend it also at the property level. So simply you could add something SAE definition as a old data type property and add this to all the signals you want to describe, and then you would have also automatically also the SAE description for the terms or signals that are found in VSS. That could be one way to do it, actually.
Yeah, I want to be honest about why I brought this up is because part of the challenge is when we talk about the same device to different teams within Ford Motor Company, they have different interpretations. A feature owner or a feature systems engineer is, they look at it, the device as like what data it gives me, versus a hardware design engineer talks about like, hey, what is the viscosity of the gas that, or of the fluid that you're talking about? What is its units? They don't. It's different to connect different worlds together. Now, if I scale this into across OEMs, there will be more interpretations. How can we reduce those ambiguities?
Sure.
Yeah, it's my problem I face
totally
within the
right.
organization. So I'm just, or should I say, venting it out? I'm just kidding. Yeah. Like I'm looking at VSS and this ontology group to provide a solution to some things that happen internally in the organizations as well, and then we address it across OEMs.
Yeah, that's really valuable input, and we are handling as well similar issues inside. And like one answer as well in VSS is that you have as well private branches, not like that you, or like some, like we call it now layers, so that you have private extensions as well. No, like, and that I mean works in the ontology world as it works for VSS. You could even then use the same tooling if you want to have like some. I mean, some things maybe you don't want to give out because it reveals some internal things you don't want to see public. No, like, and there's as well always a possibility in the ontology as in VSS as well, so that you can use the same tooling as well to generate maybe under a different namespace, but then your own private vehicle components or like signals or attributes.
Yep.
Daniel, you
Okay.
wanted to say something?
I just wanted to complement that as part of the proceedings of this workshop, we can, for example, collect like working points, and one of these working points could be as part of the documentation. We can include the way of how can we extend the ontology with concepts that are not part of VSS, for example, like providing a simple example, like doing or the 2 or 3 paths possible. One could be doing the pull request for the property VSS and then generating the concepts from there and so on. So just an opinion on that.
Yeah, that sounds good.
Okay. So so I take it as the summary wise, the existing definitions or data that we have for our ontology will be going from VSS signal specification as a start point. But if certain definitions or definitions needs to be changed or additional parameters need to be added, we can do it using pull requests. Is that?
Yeah, exactly.
Okay, great. Thank you.
Other questions or comments?
In the minutes for this, we'll have links to the repository, and Daniel and Ravi and Nick, or I don't know if either of you are subscribed to either the Covisa or W3C mailing list, but if not, you can provide me your email addresses, and I'll make sure you get a copy of minutes and recording. And as I said, we'll have links to the repository where you can make this pull request.
Thanks. I'll send it in the chat.
Okay, shall we jump like we made before? If there are no general questions on the working drafts, like we had in the repository, like a brief agenda. So basically, we started with the current status, and then we had some issues we wanted to discuss. The first one is like the subclasses versus instantiating of existing VSS concepts. So it goes into the core of Ravi of your questions, and Felix wanted to show and give a proposal there. Shall we go on with that, or are there more generic questions? Otherwise, we can jump right into the basically discussions about the different topics here.
I have like one more question with respect to the tools or the framework that you're recommending to represent this ontology. Is there any standard recommendation or something that the team is trying? The reason why I ask is when we develop this instances or related ontologies, the OWL format is very straightforward. That could be some alignment aspect like for compatibility, but if you want to see things in action, maybe we use the same tools as Covisa is using, so that it's easier to replicate the problem if we land into.
The
Yeah,
tools are used, yeah. So we, I mean, the tools repository of VSS is also the one used to generate the ontology. So in VSS tools, you will find also a converter from VSS to Turtle to turn basically the VSS specification into an ontology. Yeah.
Okay. So it's in the VSS tools folder, right?
Yeah.
I'll take a look at that.
Maybe
after.
Daniel,
Thank
you can post the link. Yep.
Yeah, I can, like if you have the repository, like this is a VSS repository, there's then a reference to the VSS tools. And there you find in contrib vspec to turtle. And this is basically basically the converter where you get this this turtle file to this ontology. And then on the W3C side, I have a tool which basically reads in the turtle file and creates this documentation out of it. So like that's the second part. And the VSSo core, as said, these are basically like classes like more general classes like vehicle or like vehicle component, different vehicle properties. Those are basically defined in, like, I use Protege, but like we thought first to have a web Protege project or something like this, but then we said, okay, like everybody has anyway different flavors of tools they're using to edit, so that's fine. Like whatever, ever you're comfortable.
Thank you.
Okay.
Okay.
Any other comments?
Then we could switch.
Pierre, I think Pierre Antoine. Sorry.
Yes.
Okay.
PA works as well.
Okay, that's easier.
Pierre Antoine is very long, even by French standards, even for French people. So, now, regarding tooling, I have a question. You mentioned different formats, including JSON and YAML. Is there any JSON LD context provided for the ontology so that a simple JSON could be interpreted as representing data that comply with the ontology? And if not, would that make sense?
Just so, like, I think you're referring to this one. This comes basically from the from VSS, from the YAML specification. So this is basically like a serialization just of the YAML, which is like, for example, GraphQL schema. Here's no JSON ID. I think it would then make sense to get it out of the ontology itself from VSSo, and maybe not from here, because otherwise you have to do the same work in two like basically in two different formats. So we get Turtle out of here, and then maybe we can use standard tools to get the JSON LD out of that. Maybe I think that shouldn't be a problem. Right now we just have the Turtle serialization.
Okay, thanks.
It shouldn't be a problem to give it as well out in JSON LD. Okay, other questions? Or then Felix, you can go ahead.
Yep. Thanks. So I'll just share my screen. What? Okay. Can I not share the whole thing? Which one is it? Too many open windows, sorry. extension proposal. Here, this one. Okay. So do you see my screen?
Yes.
Yes.
Okay. Okay, good. Come on. It's very slow on my side. Okay, so the first one is the treatment of the vehicle component and vehicle signals in the ontology. So this refers then how we generate basically, or what type of concepts we generate from VSS that extends then the VSSo core ontology. And the current proposal is to do this by subclassing. So what I have shown on that slide is that you have in the VSSo core this dynamic vehicle property, for example, as a class, and then the vehicle component as a class. And between those high-level classes, you have this belongs to relationship. And then the current proposal is to basically generate a dynamic vehicle property, a signal, a VSS signal, as a subclass, subclassing this dynamic vehicle property class. And similarly, if you have a branch in VSS called engine, this would be also become also a subclass of vehicle component. In order to then relate your signal to the vehicle component, for that to work, you at the ontology level, you have to then also subclass this property, this VSSo belongs to. You can do that, but it leads to a lot of properties, and yeah, we have looked at the topic. Here are some of the disadvantages of that approach. So you have many, you require many subclasses. At the same time, these subclasses do not really introduce any kind of new data properties, because the speed signal is still a dynamic vehicle property that might have an attribute called property name or property data type or something like that. So it's not much that you gain by subclassing that. And you need then these individual object properties to relate the different classes, and you will have a lot of them. For all of the branches, you need a separate one. I mean, that's just kind of the disadvantage of that approach. The advantage, of course, is, which I did not put here, but to be fair, I will also mention it, is that you, of course, have this then at the ontology level, at the class level, these definitions, and you can then further instantiate these classes if you want to do that later on. Well, our proposal is to change that, to really keep the core ontology with the class definitions, which are shown here in blue, fairly simple, just a couple of classes with a couple of standardized properties, like this object property linking dynamic vehicle properties, for example, to vehicle components, and to have also this hierarchical relationship belongs to vehicle component. So you can nest these vehicle components, and then to use instances for the signals. The advantages is that your ontology stays simple, so you can just use this VSSo core model here. You can reuse then these belongs to relationship, so you don't need to define new sub-properties of belongs to, and you can easier handle then the VSS evolution, so to say, because your ontology stays the same, this core ontology, unless you add new high-level properties, this will be all the same. Then you can generate, depending on the VSS version, which is evolving, let's say each couple of months, you have a new VSS specification being released. Then you can go to the VSS tools, generate your instances, but they still conform to the same ontology definition. So that's something that we see as an advantage. You can still then further, I mean, you cannot instantiate these signals, but you can link them to other things. So if you have then maybe private signals or even more proprietary definitions of your signals, you can still link them then to the standardized VSO signal definitions if you want to do that. So that's kind of the first discussion point that we should discuss today in the workshop. I would be curious what opinions you have on that topic.
Maybe I can start. Like for me, one thing is if it, like maybe that's more in the direction of or attributes in VSS. If you have something like brand or something you want to instantiate because like a lot of vehicles relate to it. No, like maybe if you have like observations like vehicle signals, I think it's often it's okay to have it as instances, and then just for example, then it's again the thinking about SSN and so and so on. It's okay to just link to the instance to give the type. But if you have something like brand or like model or something you want to instantiate, because a lot of like you want to query it, like it's a question how to realize that in this approach. Does it have to be a black or white approach? Can it be done through punning or like how that was one proposal we had last week. I heard like, or like, what's your opinion on that? How do you want to handle those things?
Mm-hmm. Yeah, that's a good point. If they are already then instances, then the concrete values need to be also instances again, similar to observations, which would be also linked to these instances. I mean, it makes things a little bit more complicated, but it's also doable for the static properties. The question is, what do you want in the end? It also depends on the use cases you have in mind. Yeah.
Exactly. There's sorry.
Yeah, this is Ravi. Should we? I think I'm not following the protocol of raising hand. I think Pierre has next question, so I'll wait for Pierre and then.
Yeah. Thanks. Felix, on the previous slide, could you? I'm not sure I understand why you say that you must have a subproperty of belongs to. I mean, I see this as a convenience because the subproperty belongs to engine is more constrained. That's what that belongs to, which I imagine is a super property of it. But I don't see this as a must. I mean, you could do this by reusing belongs to, even in that situation, couldn't you?
Yeah, but then you are no longer in the old world. Then you go to RDF. I mean, you can do that, yeah. But it's then not a fully OL compliant ontology, because you should have one domain and range for an object property and not multiple ones.
Yeah,
because then you don't know what it's exactly pointing to. I mean, you can do that. Yeah.
Okay, I'm sorry if my questions are a bit naive. As I said, I'm new to all this, so discovering a lot of things. But the way I look, when I look at the specification, I see restrictions, our restrictions. I see that's also an item in the agenda. So maybe maybe that should wait till we address that other point. But I see the way I see those things model is that speed has a restriction on what it can belongs to, and that's still possible
Yes.
in OWL using standard properties, and again without having to define specific sub-property for every combination of subclasses.
Yeah, that would be one way, or you use shackle to do this constraints, basically. Yes.
Okay, so to my question, this is not strictly a must, right? This is one way of achieving it.
No,
but
it's not.
Okay. Okay.
Yeah. I mean, the real question that we should ask ourselves, in my opinion, is what the meaning is of these signal definitions. Is it just something? If you go for the instances, then you take them as let's say some real thing. If you go for classes, then this means, yeah, there is eventually in the future, then if you instantiate it, there will be an instance of that class holding then the concrete signal. Yeah. And yeah,
Yes.
I mean, it really depends on what you want to do with the ontology. What I think is important is if VSS defines then these associations of signals to the branches, is to have a way to retrieve this easily from the ontology. And if you go for these constraint-based approaches where you put it into all constraints or into shackle, it's much harder to identify which signals are then associated to which branch, and that's something that you can easily do in VSS, and that's something that I would like to see also in VSSo, that you can write a simple query to find this out from the model, because this is I think one of the things where somebody put some thoughts into it in VSS, how to structure the whole thing, not to have a flat list of, let's say, 700 signals that are all associated to the vehicle. I mean, this is a lot of effort has been put into that. So that's something I would like to see in the ontology. I mean, how we achieve it is a different question. Yeah.
Okay, that makes it much clearer. Thank you. Now I understand what you're trying to solve here. Okay, thanks.
Yeah.
I have a comment here. So basically, I agree with the fact that this belongs to relationship, and having many soft properties of this is unnecessarily redundant. You could handle everything with the belongs to vehicle component, but the question here is more towards whether you have like an instance of the vehicle property. I see it very useful in that way, because then you can directly point to the actual definition that requires no further instantiation. But a valid point is what Daniel points out, is that whenever we need to have a sub-hierarchy in which you are defining brands or models of specific vehicles, and this is particularly the case for attributes, I think we can have a different concept there to handle those type of concepts that require further classification as a subclass, and all the rest to be an instance. My question is, if we have everything as instance, for example, in this case, speed, how the specific values of the speed would be linked to the speed itself? I mean, in practice, how does it look like?
Yes, one way to do this is with SOSA observation. So every vehicle property can be linked to an observation. That's one way of doing that. If you think that SOSA observation is too heavyweight because it defines then an observation with, I don't know, a result, which is another triple, you could do it also very simple by saying you have something called property value, which would be a separate class, maybe with a just a data property value and a property timestamp to keep it very simple. Because you need to, for the values, for the signals, you definitely need to also record the timestamp, because otherwise you don't know at which point in time you have measured the signal value. And it's a time series that you will get then for the vehicle properties, because they, depending on the sampling frequency, they can change quite often in the vehicle itself. Yeah. That's something that I would do for the dynamic properties, so to say. I mean,
for example,
we can also extend the core if we want to include that, or we say no, this is not part of the core, and we exclude it and leave it open to somebody who wants to use then the standard. Yeah.
So in practice, if I understood correctly, if you have the speed value 100, for example, and then in practice you will have a vehicle has a dynamic vehicle property speed, which is the instance.
Yeah.
But this speed is not, I mean, the value of the speed is not linked directly to the vehicle.
Sketch an example?
Yes, that will be helpful. Please.
So I'll just create a new one showing that one. So let's take this example here. So I'll copy that here. And you want to say now how this looks for a concrete thing. So what I would do is the following. So you have a speed value 1, for example, and you could say this is a, I mean, we can rename the class, but just to get the concept, or we could say this is in general a property value or something like that. And now you say this, of course, is associated to the speed, and would be, for example, have a property called value. So this would then link to the value. And maybe we define for this property value class that we also have something called timestamp. And what you can do then is to express these observations basically of the speed. Now you would have something, a literal, maybe this is 100 kilometer per hour, measured at the time 2022-03-14, and to be precise, this would be the actual time. Yeah. And you can have multiple of these instances of property values to express this. Basically, if you want to have then in your instance data all these values, so you can express time series basically of these signals. And then you can say, let's assume you have a concrete vehicle, which would be an instance, maybe vehicle 1, 2, 3, 4, 5. And you could say this vehicle, or you have multiple different vehicles, you have another vehicle that could have different signals. So what you can do then at that instance level, you could say, okay, this vehicle has this vehicle signals, and the observation is also linked to the concrete vehicle to obtain then, for example, the things, or you retrieve the observations. No, I think you have to do it that way. Because this, if you go that link, you don't know which vehicle this observation is from. So you really need to do it then that way. But it would be flexible. And if you want to add additional information here to that property values, you can also do that. Yeah.
Quick question, would you also, for every individual vehicle, would you also represent the hierarchy of components, or is the hierarchy of components only described at the abstract level?
Yes, I think the abstract level is kind of I always call this 150% model. So the VSS specification contains branches for engine, for combustion engine, for electrical engine, or for high voltage battery or things like that. But not every vehicle, of course, has a high voltage battery. So what you can do on this vehicle specific instantiation, you pick the branches and the signals that are relevant for that specific vehicle. So you can also assign, so for example, this engine to that concrete vehicle. And if you have another component, let's assume you have a different component called high voltage battery. Of course, the high voltage battery only makes sense in an electrical vehicle. So the combustion engine vehicle would not have the high voltage. So in that case, this other vehicle would have, for example, a high voltage battery, but not this, if this is the combustion engine, not this vehicle component. And of course, then also not the signals related to the combustion engine, for example. So that's possible, yeah, to do it that way.
Also, just to remove any source of misunderstanding, all the nodes that you added are not in the VSSo namespace, right? I mean, except for high voltage battery.
Yes.
Okay, so
this depends on now how we name this. This would be VSSo Core, I think. This would be the namespace of how we call this instantiation. Maybe we could call this VSSo signals or something like that, or I don't know. And this one definitely is something which is in your
something
private
local,
namespace.
right? Yeah.
It could be Bosch or whatever. Yeah, we should be precise. For example. But you can do this as you want. Maybe we, in a future version, we come also up with a common standard how to treat property values. Then we could go from the more proprietary one to even a standardized one if we want to. Yeah, but that's up to us to define this. Yeah.
Hey, Felix. Yeah.
So that's basically the idea. Yeah.
Yeah. If you can go to slide 3. So first, appreciate the approach for the advantages and disadvantages. And I like the approach of instances much better than the way of subclasses. But there is a benefit of having subclasses with respect to visualizing things or logical organizing of things. So maybe if you are going just by having one master class and everything instances out of it, we may lose certain advantages out there. I'll give you an example. If I am taking an instance of, now if you go to slide 4, if I am taking an instance of the vehicle component, it has to embrace all the properties of its instances. For example, engine has a sensor, has a speed information, has RPM information. So you're telling the vehicle component has RPM information as a master property first, right?
The way this works is the other way around. It goes from the vehicle signal. So you would have something RPM as a signal, and then you associate it to the components. This is
okay.
But it's a matter of choice whether you do it that in that direction. You could also have a inverse property defined, which is not called belongs to, but consists of or contains signal or something like that if you want to. But it's just a matter of, I mean, in the ontological world, it doesn't matter from where to where you go, because you can always also traverse the link in the other direction. So you can go from the component to the property, even if it's defined in the other direction.
Yeah,
but
I'm
I think
coming
it's
from
good
the
to have.
top-down direction. The way we are looking
Yeah.
at this activity is we are using VSS as a core and constructing an ontology on top of a flat repository of signals. Instead, if we go with the
Mhm.
real ontology approach, like looking vehicle as a source of information. Now, how do you want to classify that
Yeah.
vehicle source into logical categories? It could be, ADAS component, body component, climate rated component, that is one approach. Or you can look at the vehicle
Yeah.
as a conglomeration of IO devices, which are, organized
Mhm.
at a component. So to me, vehicle component like engine is a component. Now, if I try to instantiate a seat component, it might not have the same parameters as an engine, right? So how do you justify individuals of a class to be of same, class? To me, if we can use that classes and subclasses and individuals, it might be helpful. Let me explain with an example. So I would like to see this as a
Mhm.
vehicle component and engine still being a subclass, and then
Yeah.
hybrid versus ICE versus, internal combustion engine versus pure battery as three individuals. In that way, we may have the common data that comes out of an engine as a class and data element, while how exactly is that data coming? It can come out as an observation or it can come out as a static property specifically created for your individuals. I apply this stream to, let's say, I have a seat as a subclass of vehicle component, which has 4 switches, 2 actuators, 5 sensors, and seat usage data and seat position information as a subclass of seat. Vehicle component class, seat subclass, instances could be devices and other functionality. Vehicle component class, engine
Mhm.
subclass, RPM sensors, actuators within engine. You see that approach? So where I'm coming from is I like your approach of instances and individuals, but we should not lose that subclass advantages for logical organizing of data from a top-down approach.
Yeah, that's pretty much understandable, but then we need to design the ontology in a different way than we are actually just transforming VSS to create these subclasses. Because what you propose is also, I think it's the right way if you talk about subclassing. If additional properties are added to the superclass, something you have in vehicle component, you define that each component has a name and a description, for example. But if you subclass this and say an engine is somehow more specific than a vehicle component because an engine has a, I don't know, number of cylinders as an attribute or something like that, or a displacement or whatever, then you
Perfect
add
example, yeah.
additional data properties.
The
Yeah,
seat doesn't have
and this
cylinders,
is
engine
exactly
has.
what
Good.
yeah, exactly. Yeah. And then of course the subclasses are somehow different from the superclass because you would not have the properties that a seat has, and you cannot if you instantiate the seat, an instance of a seat would definitely not be an instance of an engine because the properties are different. Yeah.
Yeah.
We can go that route, but it's a much different approach to the ontology. Or what do you think, Daniel?
I think I think that comes back to the thing what is defined in VSS, no? And I totally agree for the vehicle components that it's not more specific and that we should have instances there because it's not more defined in VSS, no? Like it can be as said defined maybe in an extension where you then say okay, like hey, you want to have like an engine defined as a subclass of vehicle component. then connect at the end your instance maybe to the VSSo engine, which is generated as an instance. I think it makes sense. No, like the subclass maybe don't make sense so much for the vehicle component because we don't have this information in VSS. No, like that maybe should be rather than an extension somewhere else, and it cannot be defined in VSS because it like branches are as they are. No,
Exactly.
or like you would have to change VSS. So their instances make sense for signals, maybe as well, like I said, for observations and so on. You have this approach that you link to anyway to instances then, and then it's like maybe cumbersome to instantiate your own observable signals. As I said, for some attributes, I see that the subclasses can make sense because it makes sense to instantiate them with the value they carry. Like one example was brand or like model. Others or color or something like this. Others maybe should be as well direct like properties of the vehicle, like the VIN. No, like it doesn't make sense to have maybe a subclass, and maybe we can have. Even we generate like we have this layers approach. Maybe in the generation tool we can have that as well as a discussion. Okay, that we don't have to see it so black and white. No, that we maybe we can have a rough rule, for example, that like right now, just an example, you have like vehicle components and all dynamic signals that can be instances generated as instances, and maybe for attributes generally as subclasses. And if there's nuances, we can basically like have a like an addition to the spec where we can say, okay, this should be like defined in a certain way, which can be then read by the tooling and used in the transformation. And as long as it's few, I think it's comprehensive. Like it's not so bad. Of course, if every signal is treated differently, I mean, it's not comprehensive anymore. But like have rules. And then apart from the rules as well, where it makes sense, maybe have some additions to make it easier to use it. That would maybe be my take.
That's a very, very good proposal, Daniel. I think it makes sense to differentiate between the different types of signals. That's, by the way, something that I would also, I mean, on the semantic side, this is, I mean, another proposal that I had. I think I showed it once to you with the numeric properties, because in fact, what you have in VSS, by adding additional, in the YAML file, by adding additional lines to it, you change the type of the property. So if you say for example, you have enumeration properties, if you add this enumerated values line, then you basically go from a signal to an enumerated, or from a static property to an enumeration property. And I think in an ontology, you can differentiate those, and we should add them in the VSSo core, that we can easily say, okay, this is an enumeration property, because for an enumeration property, you also want to know then which possible values can this enumeration take, for example. For a numeric property, you want to know what is maybe the minimum and maximum value, if that's given, the range, or you want to know what's the data type, or what's the resolution or accuracy of that numeric property. And for a static property, that's not so important. But there, for a static property, kind of color or vehicle VIN, you also want to know the data type. Is it a string or integer? But you probably don't want to know a physical unit because it doesn't matter for a vehicle VIN. Yeah, there is no physical unit. So
not just
it
about
would
the
give
point
this differentiation of,
not just
Sorry?
the point of a unit. Those values, we can also draw a line, like what parameters can stay at the subclass level and what goes at the instance level. Expressing energy or range of your vehicle can be in miles or kilometers for distance or fuel level, furthermore. But when you're talking in terms of battery consumption, like let's say fuel economy, like I've used like let's say 20 miles per gallon, or But if you're using only like electric vehicle, I would say like I travel, 40 miles for certain power wattage, kilowatt hour of battery consumed. So those instances can go all the way at the individuals, but at the class and subclass level, it is just the property. One question I would like to ask, not just for myself, for the entire team is it necessary that whatever we capture in the VSS ontology model needs to have a mapping in VSS? For example, if I have a signal in VSS, I should make sure that it is part of my VSSo model as well. Is that?
Well, the question is, since we use this generation approach, in my opinion, the information has to come from somewhere. If it's not in VSS, then somebody has to add this after you generate maybe the signals out of VSS. Yeah. I mean, this of course we can say we extend, or VSSo is more than what VSS is. Yeah,
I see it that way. VSSo is more than VSS.
Yeah.
So
I would add to that answer that it will depend on what you want to add. So if it is strongly related to a signal that is coming from the vehicle, then it makes sense to try to include what is missing in VSS. If it is not directly a signal, but it's something that is derived, like for example, if you make use of cameras that are embedded in the car to detect some objects, and you have a hierarchy of objects that are detected. So I think that can be located kind of at the edge, like the extension of VSSo, because you are not dealing with direct signals anymore, but the derived high-level abstractions.
yep, I like that
Okay,
example here.
So shall we maybe note down here on a slide what the outcome of this discussion was? Discussion on subclassing. Oops. Classing versus instances. What did we say? Dynamic vehicle properties. Property proposal to realize as instance, static vehicle property, proposal to realize as subclasses to instantiate for concrete values VSSo. No, what's the name? VSpec
Component,
to TTL, VSS tools.
Yeah.
I will add. Define rules how to generate VSS signals.
Or exceptions or something.
In VSSo. Yeah. Rules, exceptions. And the vehicle component, we said vehicle component proposal to realize as instance, right?
Yes.
Okay, good. So we have that.
Is it the case for all the static vehicle properties to be realized as subclasses, or there is like a subclassification needed?
I don't know.
Maybe we should
I mean, I think
should not draw a line now.
I think with the points you have written, I mean, we cover everything. No, like we have some rules of thumbs, and then I think we can see, okay, like, hey, where it doesn't make sense or where it doesn't apply. No, like I think that what is written here is okay. Like I think it would take. And it would, I think it should go then on maybe on a pull request level to say, okay, like, hey, this I want to have as not as a subclass or something like this, so that we have time to think about it and like go case by case. I think for the rule of thumb, it's okay to start with it, and then we can see.
Yeah, I think the open points would be. I mean, in VSS, there are some things that are not yet covered by these rules arrays. The other one would be instantiation. And I don't mean like OL instantiation, I mean VSS instantiation. These, I think, these are the things that we still need to discuss how we want to represent that. And it's
I
not,
would add
not so
there the
straightforward
unit,
for
for
some
example.
of them. Yeah.
Unit, and also that is something that was mentioned was the making the distinction whether the property is about a quantity or a quality or a category or you name it. So the example was
Property
given with an
type,
enumeration, for example, but I would
yeah.
say you refer mostly to qualitative or quantitative properties. This is a discussion we had with Daniel a couple of weeks ago. And I think this could be part of VSSo. This could also be handled by the extension of VSSo. So I think it's good to have it as a
it's something that I have put here. For example, you have this dynamic vehicle property, observable, actuatable, and static. This is, I think, we have that already. And I was thinking of maybe it makes sense, but we don't need to put it in VSSo, but we could put it also in enumeration. So that's something like enumeration property, which has then an enumeration value or multiple, can have multiple enumeration values and a default value, because that's something that's also defined in VSS. And you can have a numeric property, but I mean, that's just a proposal how it could look like with a min value, max value, and an accuracy, and then an associated physical unit, for example.
I agree with that partially. So what I was thinking is that a property can be a subclass of both, for example, a dynamic vehicle property and what you call enumeration property. I refer as a categorical property or qualitative property, like for example, gear number, you have allowed values. So I think this distinction makes sense to have it in the VSSo, but yeah, it's still open to be discussed.
Sure. Okay. So these were the main points. Let me see. Yeah, there is one thing which is also open from my perspective. What is the vehicle? Is the vehicle something part of VSSo core? So talking to or giving VSS or VSSo to some colleagues internally at Bosch. So they came back to me and asked, what do you mean by vehicle? Is it really the vehicle, concrete vehicle instance? Or is it the vehicle component root where all the other vehicle components are basically part of the vehicle? So that was something that we were also discussing, what it is actually. Is it the class vehicle? Does it refer to the vehicle component root? Or more like to the concrete, or is it meant for instantiating the concrete vehicle instances?
I think
and there comes maybe the
vehicle instance.
And there comes there's one exception already when we think about the VIN, for example. No, like if you make it then like a data property for the vehicle, then that gets clear. No, like that could be one exception already before. You don't need a subclass, and it's a data property to vehicle. And if you directly take that maybe like into the core, like generate it as a data type property, then you see already what's meant.
Yeah, of course. Okay, so then it's clear. It means the latter, vehicle, to concretely instantiate vehicle instances. Okay.
Yes.
Good. Yeah, these were basically my points.
Just one question. Did you guys also were the ones who proposed the use of specific units, or was it someone else?
I think so, yes. But I mean, that's something that we don't have to define. I think what we should define is that you can link a signal to a physical unit ontology. But I mean, I would be fine if we say it can be any kind of unit ontology. Yeah. What we need to leave open then is the range XSD, the RDFS range of this object property, because if we define that range, then we would bind to a specific physical unit ontology. But I would be fine if we leave it open. But for the VSSo tools, it would be good to have then at least some preferred unit catalog, because then we could directly translate the physical units that are given in VSS into the concrete mappings for the unit catalogs. I mean, or we could come up with different mappings for different physical unit catalogs, so somebody who wants to use it can then choose which one suits the user better. Yeah.
We have since a couple of weeks, we have that like as a config file, the units, and as well category for units. So we could add quantity kind, and like we could even take that out of VSS, and like if we need changes there, we can have that as well as a pull request there. But I would recommend to use that. So but it's pretty new. It's since a couple of weeks.
Yeah.
Which could take that.
But you have, which one did you use? QUDT or QUREC 20?
I mean, in VSS, it's not linked to an ontology yet. In the discussion with Danielle on the whiteboard, we had QUDT, but we can because of the quantity kind there, and then we looked at how we could take that information out of VSS, and there we saw we remembered the config file, which could be used for that.
Yeah.
Yeah.
Yep.
If I recall correctly, the outcome of that discussion was basically that VSS has defined a specific unit, and that is the intention of VSS to provide like a standardized way of naming the signals, and these signals are expected with those units. In VSSo, though, is a bit different because you have more like a broader spectrum. And what I was arguing is that instead of mapping directly the unit that is expected for the property, you can add the constraint to the quantity kind of what this property is measuring. So in that sense, you can use any of the units that are compatible with this quantity kind. And this is handled by the ontologies like the QUDT, for example, because they have kind of a dimension vector, and you can check that, and you can even convert between the units. So I would vote for having quantity kind as a way of expressing what is expected from the property.
Okay.
One remark.
So this means that we are not.
What I mean is like
isn't in VSS. Yeah. For me, it's clear what you mean.
What Larry said is yes, you already have defined the dimension. So here would be about defining maybe a recommended vocabulary for the units and quantity kinds, so that we can like simply link what is expressed in VSS to the expected quantity kind in an ontology.
Yeah, but let's say if we have the engine coolant temperature, and in VSS it says it's measured in degrees Celsius. Are you saying then that we should put it to quantity kind unit of temperature or quantity kind temperature, and then somebody can choose between degrees Celsius, Fahrenheit, or Kelvin?
Yes, that's what I mean. Like you can keep it open, unless the intention is to fix a specific unit. then I think that would be the way to go.
I mean, it depends on what the consumer of VSS wants to see. I mean, I agree that the thing you propose is more flexible, because it, especially if you have this typical thing, European US, US guys want to measure distances or speed in miles per hour, and Europe we have usually kilometers per hour or things like that. Yeah.
If I may, what is more flexible for data
Or we
producer?
could,
Can you
or
hear me?
we could have both. Or
Oh,
we could
sorry,
have both.
I think we lag a bit behind PA. I think you raised your hand since a bit. Please go ahead.
Sure.
So, yes, sorry. I think yes about flexibility. I think the problem is that more flexibility for the data producers means more complexity for data consumers, and vice versa. So I think it's attractive to generalize the notion of temperature to some to multiple units, but that means that consuming the data will become more complex. And I also think that it would be even more complex if you leave it open to which ontology of units producers can use. If you leave that also open, you might have big interoperability problems. That's my gut feeling about that.
Yeah, I completely agree, and yeah.
One interesting
it's a matter
alternative for
of
representing. Sorry, just last point. An interesting alternative about representing units and physical quantities is this. I put it on the chat. It's basically a data type or family of data type, but there's an overarching data type. So instead of using an ontology where you describe your quantity by several triples, you put this in a literal where you express the quantity and the unit in a standard way. But just
to comment on that, I have seen that before. Unfortunately, that is not fully compliant with the old language. So the preferred way is to have the unit specified as an individual, and then you have the basic data types, string, float, double, and so on, connected to the literal of the actual value of the property. So I think that's a drawback of using, for example, specifying kilometers per hour in the literal. So that's not fully compliant.
I'll be interested to discuss how it is not fully compliant, but maybe offline. But yes.
Yeah. Okay. I see. Yeah, it's to even further strengthen this discussion. There's also an ISO standard for defining units. The problem is that there are so many out there, and it's hard to pick the one that is most has everything in it. Not so easy. Yeah. But I also agree. I mean, it would be better to pick one and say this is the one that we refer to, and if somebody wants to use then a different one, they can do so. But at least we have defined something. And the second thing is also true. If we say for example, the engine coolant temperature is returned in degrees Celsius, then the data consumer knows exactly, it's degrees Celsius. Okay, maybe I have to display this value in a UI to English-speaking people. So I choose to convert this now to Fahrenheit, but that's then on my side, on the data consumption side. But at least the interface is clearly defined that the data provider has to provide this value in degrees Celsius, and the data consumer can rely on degrees Celsius. Whereas if you say the unit is not precisely defined, then it should come with the data itself. And it definitely produces more complexity at the data consumption side, because you have to deal then with maybe one data provider is sending me the value as degree Celsius and another one as degree Fahrenheit, and the third one maybe in Kelvin or something if it's a temperature. Yeah.
Yeah, it's a trade-off. I think it's hard. Like at the end, that goes. I think at the end back to voting at the end, because I
Yeah,
think
exactly.
different. I think you can't agree on this. You have on both sides. You have pros and cons, and it just everybody should come out with their use case for themselves and then vote. And I think you don't get a consensus on that.
Sure.
It's hard. It's hard.
Yeah,
convinced
it's funny. It's funny is that you bring up voting, because we had also internal discussions on similar topics, and in the end we resolved to voting and said, okay, this is a group of 10 people. Who is for that approach? Please raise your hand. And who is for that approach? And then we define it, because you reach then some majority, and that's fine. I think for some of these topics which are really hard to decide on. Yeah.
Even for yourself, on which side you're at. But I'm with that one. I like the quantity kind of approach, but I see the other reasons as well. I don't know. I think that we would have to. I think either we reach consensus, or otherwise you have to vote.
Yep.
What would
okay,
be the take here?
Yes.
We leave this open
I
as a potential discussion.
I think we would have, my opinion is we would have to see it now, as we have, I think, with the I mean, I have the agenda open. I hope you can see it. We had the subclasses was instantiation. I think we got a good rule of thumb, and there we have as well to see how it feels like, and maybe do some adaptations. Then the third one is as well resolved, because it was related to the first one. And once we have done that, and we add then the restriction, I think that's something we have to see and maybe then experience, and I don't know about the other things, but I don't know if we are ready to say, okay, if we go the one way or the other. I think for now it would be a good rule of thumb, and then we can see how it looks like and how it feels, and maybe have some queries. I think that makes it then maybe easier to decide. I don't know what the other guys think, but that would be my proposal.
Yeah, I think examples would definitely help to understand, I visualized it, and then it's easier to decide which one you are for.
Yeah. Okay, Ted, you had as well one point. Do you want is there something urgent on the technical side still we would like to discuss now, or otherwise there's we touched it a bit, but it's the code truth and workflow topic. Ted, do you want to introduce?
I think workflow topic would be good. Yes, don't worry about the point I was going to bring up. Or sorry. You mean as far as what you're displaying right now, as far as concept of truth? It does sort of tie in somewhat to this conversation. Well, more earlier.
Yeah, I think that we touched a bit, and we had some maybe we need some guidelines there, or some suggestion for documentation. Like what Daniel said, how to basically decide, okay, do I extend VSS? Do I create an extension for next to VSSo on top of VSSo Core, or should it be part of VSSo Core? No, there I think we need some documentation. But the workflow you meant how to what do you mean with that one? Exactly what is open here?
Yes, it's open there.
So you mean with the workflow?
For workflow, yeah, for workflow, I think it would be good to document this. I mean, how to the things you explained in your presentation, in the opening presentation. I think this is not known by everyone, that you can use this VSS tools to generate then the signals for the VSS ontology. Yeah.
So this maybe would.
Or is it in there?
No, I think not in.
Okay,
Like
I haven't seen that
not
one.
in
Yeah.
depth.
Yeah, that's good.
But there, somewhere there, I think we need the documentation. It's not complete. I think especially like this question, how do I extend, could be an additional point. Additional point.
Yeah.
So for that, probably, and Kareem might have some other ideas, but I think it could just, what we should do is come up with some sort of guidelines or suggestions on how to do derivatives, so do extensions. And once we decide what that should look like, to try to avoid things just going all over the place, which would be the tendency otherwise. And then include link to documentation that explains how to use the tools to do the derivatives. That would actually facilitate and encourage people to abide by the conventions that we decide. We like to encourage people to use as doing VSSo extensions. I think that would make the most sense.
Yeah, that's true. So like we can take that as a point, like that we.
Yeah. Earlier, I thought your topic that we discussed last week, and I added, it's on the on the issue that you're displaying right now, number 26, as far as the agenda for this was Alan Friedman from Autonomic was worrying why we're using VSS as the core truth, because it's not as rich in what it can represent compared to an ontology. It's a lot easier to dumb things down as far as representation for the core truth. So starting out, wondering why we didn't start off from an ontology and produce the YAML from that. And that's sort of ties into what we're discussing right now too, is something for us to consider and also bring back to the regular VSS group. Most of the people in Covisa and W3C automotive activity are more automotive engineers instead of data scientists, and they're the ones that are coming up with the signal definitions, and we want something that is simple and straightforward to them. So we actually thought about doing sort of a circular approach where they continue to basically make suggestions, proposals in YAML, and through tools we take that as input, as requirements for what can go into VSSo, and tooling for VSSo can produce YAML. Then we can sort of compare and see how close we get to the what the proposed contribution is. But I don't know if we actually want to get into that here, since we have to try and sell the idea to the broader group first. But it would be worth getting a little bit of input if people want to sort of share their thoughts, because it's harder to, Daniel's mentioned using through configuration, you can in the tooling you can add additional information when you generate VSSo. So it's sort of, you end up having to maintain essentially additional information to sort of add on, and it can be more cumbersome and or easy to sort of miss those opportunities as far as things get defined that you should have done a richer definition to begin with, and figure out how to bolt that on after through configuration and tooling. So I'm not sure if we want to discuss that now, or just maybe just get a little bit of statements of encouragement that we should try to bring that back to the Covisa VSS group and see if they're open to.
I think from my, I think the cleaner way would it would be like to basically create the YAML from the ontology, maybe as well with restrictions and rules, maybe through Shackle or whatever, but that you can say, okay, like, hey, these concepts I want to have in this way with maybe those restrictions on in YAML, and create to basically have then the definition, or even to GraphQL or something like this. It maybe would have more sense, but like looking at the history, I think it would right now just mess things up. No, like, and I think with the two namespaces and with the core and like basically the generated part of the ontology, I think we found a compromise we can live with. No, like, and which help. And if we make it now a bit more adaptable, that we don't have so strict rules, and look maybe as well a bit into the naming, like that we don't duplicate all the names or something, that we make the tooling a bit smarter, I think we come to a, like in a really relatively short time frame, to a acceptable and good solution, which can actually be used really well. So I wouldn't, like, I have a bit of fear if we go to Covesa, or like, and say, okay, like the ontology should be the basically the major point, that would mess up a bit the momentum VSS has right now. And on top, if we would then say, okay, like we allow it in both ways, it's almost the same as for the quantity kind discussion. No, of course it gives more flexibility, but it comes with a cost in terms of tooling, and which has to be maintained and so on. And we don't have so much workforce behind in VSS tools already, like to create the tooling. And I think at the end maybe it's a bit too much, but that's just my 2 cents.
It would be a challenge to, well, one, convince people, then two, create the tooling for a circular approach would be cumbersome with the number of people we have.
Maybe I can provide my own 2 cents here. I think if the community around VSS is happy with the YAML file and contributing to that, then well, if they ain't broke, don't fix it. If I hear Daniel correctly, the constraint might be on maintaining the tooling, which is indeed which also requires some commitment. But if the commitment is if the effort is less, then having the whole community adapt to OWL or something like that, I think it seems to be definitely worthwhile. And for what it's worth, I'm also exploring a similar path in other fields where people are used to JSON schema in order to define their own vocabularies. And I'm also investigating how JSON schema could be used as an easy way into ontologies, and let people use JSON schema the way they're used to, with some additional constraints and annotation in order for us to be able to generate ontologies. So a very similar approach, I think. If that's the way to bring other communities to designing ontologies, even if they're not quite aware that they're doing so, well, so be it, I think. My 2 cents.
Sorry, I agree completely, but I think I expressed myself not correctly. Like, what I meant is like to have tooling in both ways, no? Like to say, okay, like, hey, we can extend from, or like we can basically generate the ontology from VSS, and we can extend the ontology and like bring it back to VSS
okay, sorry.
YAML specification. No, that was, I think I expressed it correctly. So I think that would be a double effort, which would like that we should just like say, okay, like we go one way, which is from VSS to VSSo, and that's it. And this tooling we can maintain. But I think if we go with the tooling in both directions, we lose some workforce in basically for something which is maybe not so much needed. to basically have both ways, like from the ontology to YAML and from YAML to the ontology. I think,
Yes, of course,
if
that's
we
much
have,
more challenging.
exactly. And like about your JSON schema, it's really interesting. Like I think in VSS we have one advantage that we have, like in the tree we have built, we just have one relation and we are in one single domain. Not like a vehicle component you could discuss a bit, but like still we are like in a domain we have the similar approach we had like with person. No, like but there you're already like pretty quickly in multi-domain, no, like with different kind of relationship, and then it's not so easy anymore to have it like in the YAML way, no, like, and then you start to add relations, and at the end you create your own your own owl, or like your own RDF, and but I think we are fortunate in VSS that we are in a clear domain with a stable relationship in the tree. Like we basically have just one form of relationship. In other domains, I think it's much more challenging than in the vehicle domain as we have it now.
Yeah, I totally agree.
Okay, one topic I would like to discuss is and that goes more in that maybe in Karin, in your direction, how we continue with the with the work we decide on now. Like, is it now officially part of the working group, I guess, and VSSo is discussed there, or like is it like how shall we basically really start working, because that was as well meant as a kickoff workshop that we make the first discussions and decisions, and then extend it and start the real work on it. So maybe Ted, you can, or Karin, you can give your input.
So it is now formally in the tree recommendation track, it being VSSo, and the working group has one call primarily focused on VISS, but other topics are sometimes included. It may make sense to have a sort of a dedicated call, dedicated group. Anyone and everyone is welcome to provide feedback in GitHub repository. Observers are welcome. If we do have a separate breakout call, for sure. People that are making contributions for the sake of IP clarity it's best that they are, or even required that they are in the working group. So I this is so what we should maybe do is, so that is certainly one of the thoughts I was going to have as far as next steps and how we should go forward toward the end of the call, but we can certainly go into it now. Is my thought was to try and get a sense of who's interested in helping define VSSo, who's attending here. We have other people who unfortunately aren't on this call that we've been in conversation with. Today maybe just wasn't a good day for them, scheduling wise. But we hope to encourage to contribute to this. The person I mentioned earlier from Autonomic, Alan, for example, had a bunch of good ideas. He shared with Daniel and I last week. So if there is interest, and we could figure out how to schedule that call, probably do one of those dreaded doodles, which are such a pain in the neck, but also very useful because I can't always count properly differences in time zones, especially when like today messed up with daylight savings, shifting things around. So hoping Ravi and Pierre-Antoine and well, Felix, obviously, who's been part of this, and both Daniels and whoever else is inclined here and elsewhere to participate. We certainly would welcome that. We want to not only have a solid ontology that makes sense for the industry, but we want people at these different companies to not go off and create their own If they're doing extensions like we're just discussing, it might make sense that we sort of describe what are some recommendations on how to do that, and even how to leverage the tooling to do so. That's to hopefully not to try and reduce incompatibilities in the future. It will be a good idea. So I'm not sure. I guess I'll pause there to see who all is interested. I think we'd probably start with a modest sort of bi-weekly cadence. We may decide that we work more or better in GitHub issues and need to meet less frequently. I'm not sure, but first let's see who's interested in taking this excellent start of VSSo and how to do some of the various changes that we've been discussing so far, and others that are in consideration.
Ted, just a clarification on the IP. We welcome contribution from non-participants from the groups. We have the mechanism in place for clearing the IP issues. So
I know for invited experts we do, but including contributions from
any contribution coming from GitHub can get clearance.
Excellent.
That means putting the right commitment when we ask the person. It requires a specific commitment, but it's not mandatory to be in the group.
I got this email for this from W3C about patent policy call for exclusion. So this is, I mean, if we contribute, then we first will check whether something is, I mean, but that's clear. Did you also receive that? I mean, this is a question to the other participants in the group.
Yes, it's for all the participants in the group. It's triggered by the publication of the first public working draft. And there is a 6-month period when exclusions can be made. So it's including claims from the patent policy, the royalty-free commitment.
Okay.
So basically it means that if you want the standard to be royalty-free, you don't have to exclude anything. You don't have to say anything.
Yeah, sure. That's clear. But I mean, for VSS...
Sorry, go ahead.
For VSSo, it's kind of an interesting thing, because the VSSo specification, if you take it correctly, is derived from work from VSS. So if any party puts a signal into VSS, it will automatically then, I guess, Daniel, with the conversion tools, then appear somehow in VSSo. So that's from a legal point a very interesting thing, because you are not directly, I mean, if you contribute something to VSS, then you automatically somehow contribute also to VSSo. I mean, just people need to be aware of that fact. I think that's the only thing. Apart from that, I think that's clear. If you are contributing, then it will become like a public standard, and you will not exclude it somehow. That should be clear for everybody.
Covisa has some concept of IP for contributions, at least, or a scheme of licensing that I'm not a lawyer and haven't done a full compatibility.
Neither I am. So I just
that's
wanted to bring this up.
There is certainly a little bit of hand waving and by things need to be, as far as since VSSo just graduated from the business group, automotive and transportation business group, to the automotive working group, the W3C council wanted a final business group report, and there's the group was informed that we were making that publication, and they had reminded people that they in the business group also made IP commitments and gave them the opportunity to make objection, and we did the same for first public working draft. So if people miss, it's possible something could have come in from Kavisa that wasn't from a participant that's not in W3C, but everyone who's been in the W3C groups had the opportunity to make any patent declarations that could have complicated things and did not. But hopefully that things aren't going to get sticky going forward. But it's always a risk in these sorts of things when we try to mitigate heavily on the W3C side between the membership agreement and the individual contributors agreement as well.
But shouldn't that be covered from the VSS side with Mozilla Public License? Isn't that they already grant contribution, like royalty-free usage, like worldwide? I mean, I'm not a lawyer either, and I don't want to say anything that maybe it should be off the record. But I would say, that should be.
We should pause the recording on this part or something. But, anyway.
But I think that it should be that the license in VSS should be covered.
Yeah, Mozilla Public License is pretty generous, for sure.
Yes.
But I don't think anyone here is a patent attorney, and we should maybe table this conversation and let if something does come up. I do know that some participants do regularly. When people get involved in W3C and other standards and trade associations, the IP part is usually slows things down the most as far as getting companies to agree to participate. So that's always a challenge. And but once people are in, it's generally supposed to be relatively smooth sailing. And on a case-by-case basis, per specification, and as more features are added, there's different periods in the W3C standards process where there's a call out to the group that we are going to do at the charter time, at individual publication times, that people are say, hey, I have patents and I do not license them to on a royalty-free basis for this specification, and then that causes enough of a flurry of events that a bunch of lawyers get involved and things come to pretty much a grinding halt until it gets worked out. But fortunately, it doesn't happen very often.
Okay, but for the next steps, sorry, I didn't want
to. For next steps, so hoping that some of the people that are that are on this call that have been participating, we can encourage you to get involved. Ravi, well, I don't know if Nick is back or not. The participants.
Yeah, I just got in 5 minutes ago.
Yeah. If you guys are interested, and also, if you want the minutes and recording and such, do make sure I get your email addresses, unless you're already subscribed to the W3C or Kavisa mailing list, in which case you'll get it. But if you're not, make sure that I have that, and make sure to include you on email for a doodle survey as part of our follow-up. Sort of figure out who wants to get involved in helping define this, helping shape this.
Cool. I think I'm on the CVI mail list, but in case I'm not, I sent you my email address on the chat about an hour ago.
Okay.
I am not seeing that. Oh, actually, I have two different clients open, so you may have given it to the other one.
Ah, sorry.
Yes, I got it. I got it.
You got it. Cool.
And I didn't know that what company you were with until now. BlackBerry. Right. And
Okay.
same
And
with
then,
the,
yeah, sorry.
Nope, and just Ravi as well, if you can. Go ahead, Daniel.
And then what I could do is like basically have the at least what we discussed with subclass and instantiation that I added to the tooling, that we have something to discuss next time we meet, if that's okay. And, okay, anything else on the which you guys would like to discuss topic wise, or like are we for now set to move forward, like the base? I think the biggest elephant in the room with the subclasses and instantiation, we have at least a proposal. Is the units we built then on top of it. Is there anything else you want to discuss now, or like as well for the next steps?
I have some minor comments, but I'm not sure if they are a good fit for discussion now. I can quickly like enumerate them. I didn't have time to raise an issue, so basically, for example, one of them is in the core model, there are the definition of has a static vehicle property and has dynamic vehicle property as relationships. But I think there is missing a simple has vehicle property relationship. And the rest could be handled with expressions that capture the pattern. So what I mean is like avoiding having many subclasses that are specifying the connections between classes, but rather just having one relationship that says has vehicle property, some vehicle property. Again, I didn't have time to raise the issue, so I don't know if it's a good time to discuss, or probably in a future discussion.
I think it's always easier to see the example then, and then maybe it makes the discussion easier. So then, I mean, there's no big rush to do it, no? Like maybe if you create an issue and then it's maybe, or like if you can show, then it's easier for the discussion.
Mm-hmm. One more thing is that the core, the actual value of the properties is handled by this data property. I think it's called vehicle property value, and the timestamp property value updated at some timestamp. In practice, though, if you want to use this, I'm just wondering if the intended use is to use the same ID or the same URI when you use this to access the value of the signal, or you will have different URIs for different observations. I mean, for this core use case of the ontology.
It depends on what you define as core use case. No? Like, I mean, if you say like this, like if you go back to the use cases, if you have like this digital twin use case, maybe you just have always the latest. If you're interested in time series, you can have like the suggestion Felix made before, so that you say, okay, like you have like a dedicated VSSo class for a simple observation, let's say, containing both, or like if you go full blown with Vss and SOSA. I think if you want to have a time series, I think it like always depends on what you're looking at.
The reason I'm asking this is because if you are planning just to accessing the signal, you might decide to take the same URI all the time, but that will imply you deleting and update and inserting again to the graph you are dealing with. So that was not clear. I mean, the use case is clear. The core functionality is accessing the signal and the value at a certain time. But how this in practice looks like, it was a bit confusing for me.
I think it depends completely on your use case. Sorry.
Yeah.
Oh, go ahead, Felix. Sorry.
No. I mean, I completely agree. It depends on what you want to do, and if you want to go for multiple values, then I mean, with different timestamps, then yeah, there are also different possibilities how to realize that. You can do that with named nodes in between, which have then different eries, or you could generate blank nodes or whatever. I mean, this pretty much is then at the level of the, let's say, at the of the instantiation of the data, how you want to treat that. And each approach has advantages and disadvantages when it comes to querying the data. Yeah.
Okay, I get it. It was unclear before, but so now what I get is, like, we have the definition of the model, and then we are not restricted to use these particular concepts in any specific way, but you can adapt to what you need.
Yes.
Yeah, I think that. Yeah.
Since we said that that this observation topic is, I mean, if we leave it outside of VSSo core, this gives the freedom that somebody says, I implement this with a simple observation concept where you just store the value and the timestamp. Somebody else says, no, this is not enough. I really need SOSA or whatever they are using for dealing with their time series data. And if somebody just has a very simple use case and always needs the latest value, the freshest value, so to say, of a signal, then he could do with a simple thing to add something like one thing storing the latest value. Maybe this should be also part of the documentation that we state how this can be done, because I guess it's a kind of a question that you will get immediately. Yeah, now I have defined all these nice signals. I have them in an ontology. That's great. But how do I deal with real values of these signals? So we should, but I guess it's already there, right? At least this extension, how in the direction of SOSA SSN, right?
Yeah, what you mentioned, for example, the use case. What you mentioned about the accessing the latest value of the signal. What my question was towards, like, is it implied that when you are trying to access the latest value, it is implied that you are using the same IRI, and then you are just updating the value, and this update process, that's what I mean, that you will need to delete a triple to insert another one, because if you include many triples with the same pattern, then you will have like a lot of objects at the end.
Yes, of course. Yeah. That needs to be done. Yeah, if you take a graph-based approach and you want to frequently update this, the only way is to delete and insert the triple again with the new value. Yeah.
Okay.
Okay. Any other topic we missed or we would like to discuss today?
Regarding the subclass versus instance discussion, did anyone consider using the punning features of OWL? By that I mean that OWL2 allows you to treat classes as both classes and instances, and there are some restrictions in what you can do with that, but it seems to me that it could be used to solve the problem of having an easy way to query the VSSo model itself, the problem that Felix explained to me a moment ago, by looking at those every signal as an instance with simple properties between them, signals and components as instances with simple properties between them. So we could explore the abstract hierarchy defined by VSS, but also as classes with OWL constraints between them, which would allow to keep the, well, cleaner in my view, but I understand this is subjective and it, it depends on your use case. The cleaner design where those things are classes and instance data are actually OWL instances of those classes. So was it considered or?
From last week we talked to, as Ted mentioned, we talked to Alan, and it was as well his proposal to have it then to use punning for that one. I think we haven't discussed that in detail. At the beginning, it was like at the very beginning of the conversion, it was not intentional punning we did. That was a result of the modeling approach we took that back at the time, and then we said, okay, we want to have a cleaner solution without punning, but without discussing the pros and cons between it. So I don't know if anybody else has an opinion on that, but at the time it was like we found it a bit confusing. But I'm like on the punning topic, and I've never used it, so I would be grateful for opinions on that one. That's something I
is it? I mean, I'm just reading here about punning. It's the first time I come across this. I mean, it's interesting, but is it kind of implemented in any kind of tool set?
I think that the standard, well, the usual OWL2 implementation support it. I expect Hermit to support it. Someone doesn't like punning here. Sorry. Any rule-based implementation of OWL, that is the subset OWL-QL, would naturally support punning, because punning is really an issue for expressive description logic based inference engine, but and so that was not part of OWL1 because of that, and they found a way to finally introduce it in OWL2, which from an RDF perspective is more natural, because this strict distinction between classes and instances is not very natural in RDF, and
yep.
So yeah, it can be seen as a hacky way of modeling things, but I think when it's done consciously and considerately, I don't consider it as bad modeling. On the contrary, it can be an elegant way of solving that dilemma between the two approaches. If I can help in any way, I'm not sure exactly how, because again, I have a lot to learn on VSS, but
If I'm correct, this punning is resolved by the reasoner. Is that correct? Well, I mean, in practice, the reasoner will decide what if you're referring to an instance or to a class.
So what actually happens for the reasoner is that, and that's why it's called punning, because from the perspective of the users, we are talking about the same thing, sometimes as an instance, sometimes as a class. From the perspective of the reasoner, there are actually two distinct things: the instance and the class. They just happen to have the same IRI, the same name, but description logic based reasoners, so our DL reasoners, internally consider them as two distinct things. And that's why there are a few corner cases that could bring surprising results when you use punning. But in most cases, it's invisible to the user. And so you can have something that is a class, that is, it has instances, it has superclasses, but it can also be seen as an instance. It has its own properties. And so it could be directly linked, for example, to a component class could be linked by a dedicated property to the upper component in the hierarchy, for example, or to the signals that are the leaves of that container. So we could have a very natural and easy to query representation of the VSS hierarchy between those things considered as instances, but also consider them as classes when it comes to instantiating concrete data.
Why I said like that we did it like not consciously. It was at the beginning that we said like, okay, like basically the vehicle components as described before. No, they are more like instances in, like it's more taxonomy defined in VSS without any additional values. No, but the name is basically reserved through and they are useful for sorting in the hierarchy. So at the very initial thought was, okay, like to have that as instances, and then have like like an object property from a signal. This belongs to a vehicle component, not like then to the instance, and then you have like that's basically what you do at the end. No? Like you create basically an instance of the signal which you have defined as subclass, and there it's basically where the punning comes into place. But then we thought, okay, like hey, maybe that adds complexity, and it's hard to understand. And that's where I read about the corner cases, but that's already a year ago. So if you have any it's definitely an exciting topic to revisit again. Like apart from the discussion we had before, which can be, I think, done quickly in the tooling, and we can first start with that. But it can be definitely when we see, okay, like hey, maybe that's not sufficient. No, like or like even if we have another example, I would be excited to learn more about it. I'm definitely far from being expert or like knowing enough about it to decide.
One more thing, and to be perfectly clear about that, when I say that the hierarchy, the VSS hierarchy could be represented using simple properties, actually I'm taking advantage here. Well, in the tooling I have in mind, I'm taking advantage of the fact that the ontology is generated from something else, that is the YAML file. Because to be totally honest, there would be some redundancy to be added, because for this to work as expected, you would need to generate both the property between those instances, those things seen as instances, and also the restriction axiom between the things considered as classes. And so the trick is actually to duplicate the information. But since those things are generated automatically, maybe this is not too much of a cost. It might create something that's obviously more complex, and so maybe harder to understand. That's the risk. But on the other hand, you would kind of have your cake and eat it, having both the instance view and the class view. So I think it's worth considering, but
Yeah, definitely. I think it's at least to as I said to learn more about it and to see how it. And I agree. Like as we are generating, it doesn't we would keep aligned anyway.
Okay.
Perfect.
Maybe
Anything else?
Daniel,
on the list?
Daniel, one last question. Did you get any feedback from Paul regarding our planned presentation on this Covesa AMM?
Yes, he wrote on. I mean, I think we just have to plan when we do it. Like there was like one was like if 3 hours are enough to have a VSS workshop, and I think that could be part of it. Then we just have to see
Yep.
when and where we do it. But I think it's possible to have a presentation on it.
Mm-hmm. That sounds great. Yeah. So when's the workshop
Okay.
planned on which day? Do you know?
I don't know. I just got on, I think Friday night, the message of if 3 hours is enough. I haven't checked the wiki today, so I
Okay.
have to double check.
That's good. Yeah. Yep. Good.
Okay. Anything else which is still open? Or?
No, not from my
Probably
side.
pretty good for a kickoff, and it was nice. I mean, getting deep in the weeds and getting some sound advice from Pierre and Antoine was very helpful. And it's also good to have long outstanding issues discussed in enough detail that we can actually resolve them, come up with a proposal. So certainly, well, I wouldn't say resolve, since we have some design decisions to make still. But great. And it's great that we are getting more eyes on VSSo now that it's formally on the right track. So that's also very helpful.
Yeah, really nice. Thanks a lot for the good input and the discussion. Looking forward to go on with it. I think we have enough work on the table now. It's nice that we can, and some agreements. That's good.
Yep, great. Thank you
Daniel,
also from my
before you
side.
close
It
up
was
the
really
session,
good discussion.
yeah, Daniel, before you close up the session, I wanted to ask if should I present insight or a brief overview of what extension of VSSo looks like to handle data streams, or do you have anything else?
From my side, it's okay, or we take it as like, I mean, we have the one task like for the documentation on how to extend signals and code, that we take that then as a first issue once we meet on that one, or we can do it now. I mean, like the question is like for the others, if you want to have I think 10 minutes presentation, you said, no, like now, or if we should take it as part of the of this point. What do you guys feel?
Either is fine by me. While people are deciding, Daniel and Felix, can you please send me a copy of your slides so I can make sure they get linked to the minutes before I forget.
Sure.
Of course. Maybe like I mean,
then,
now we have 15 minutes. What? Sorry, go ahead then.
No, I was just about to say that like either possibility is fine for me. I can even shorten the presentation to 5 minutes just to give you an insight and maybe gather a couple of opinions.
I think you've teased enough that you probably should go ahead.
Yes.
Okay, so can you see my screen now? This, do you see the screen? Yeah. Okay, so basically, what I'm working on right now, it's I call it the XDVP. So it's an extension to the dynamic vehicle properties that have been presented briefly today. So you know now that we have this core ontology on top of this, or based on this ontology, then some concepts are generated from VSS. But there are cases where you need to express something else, and so these are the concepts that are generated in the core ontology, for example. And the focus of this extension is in the dynamic vehicle property. And to be more specific, when you handle data streams. So I was working with this following a well-known methodology where you define the scope, ontologies that you reuse, terms that you have interest to have in the ontology, what are the classes, what are the relationships that are included, what type of constraints, and the instances. I have no time to cover all of them, but I can give you an overview of them. So basically the scope is extending the dynamic vehicle properties to handle these so-called data in motion. You can think of it as time series data, or more generically as data streams. And the reason why we need an extension here is because there are some questions that are not handled directly by the model, but they are also relevant, like, for example, events that occur in a particular journey of the vehicle, or questions about the driving journeys, aggregations of the driving journeys, like how many journeys a particular vehicle has in total in the last month, in the last 10 days, and so on. Other questions like methods and parameters for aggregating the streams of data are also desired, among other questions that I can further discuss in another session. What I'm reusing here is, of course, the core ontology. That is what is extended at the moment. So recommendation from the W3C about the semantic sensor network ontology and the SOS ontology, which is a light version of semantic sensor network. This is particularly useful for low-level description of the observations. But in cases of aggregation, I found an interesting ontology called IoT stream that lets you model events and stream observations, like aggregations of a certain stream. And for the units, to specify units, I'm reusing the QUDT ontology. So on the terms that are of interest, for example, we have here events, time windows, like when the window ends, when the window starts, the stream itself, the topic of the window, and so on. So for discussing classes, properties, constraining instances, I think it's much easier if I show you the diagram that I have been dealing with. Just a second. Can you see the diagram, or are you still seeing the PowerPoint presentation?
See the
I
diagram.
can see the diagram.
Okay, great. So when we use directly SOSA to represent the observations, we will have two things. Like we will have background knowledge or the static information that is modeled, and we will also have this part over here, which is what is holding the dynamicity of the signals. In this case, we have observation and actuations, and this connects to the vehicle ontology in this way. So you have a vehicle that is a subclass of a platform, and it implements a certain procedure, or you can observe or act on a specific property. Something similar with the IoT stream ontology, where you have here a dynamic vehicle property that or a data stream that is related to a dynamic vehicle property, and from this data stream you can express events that occur in this signal, like if there is a peak in the signal, or if there is some error in the measurement or anything else. And stream observation, for example, when you want to aggregate, instead of having hundreds of measurements that are hundreds of observations that are telling you that the gear number is 5, for example, you will say the stream observation has a result of 5 from this time to this time. So you save space and bandwidth if you use this in practice. You will also have concepts of analytics, and what I include here is a topic for identifying the streams, because when you use this in practice, you might face the case when several streams are derived from others, especially the case when you build models that are consuming data, vehicle data from 2 or more data streams. Joining these ideas into what I call the XDVP. So the idea is that a vehicle can have multiple journeys, and each of the journeys will have several streams of data. In this case, we have a vehicle journey that is connected to the concept vehicle in VSSo. And it describes an IoT stream, data stream, and this data stream can be either numerical or can be categorical. In the case of numerical values, you define restrictions like, for example, the observed unit must be defined as one of the instances of a QUDT unit. And in the case of categorical data, you don't have units, so you have a restriction on being like unitless. Similar to what I expressed for SOSA, in this case, the streaming scenario is handled by these concepts over here. In the case of time intervals, you directly express this with window start and window end. And if you have like something that is occurring just at one instant in time, then the start and the end of the window will be the same. This is in like a brief overview of what the model looks like. And so I think I had something here.
Okay, so far I understood it. So the question is, do you couple this then with stream processing, like on the data side? So you would run the time series stream through a stream processing application or whatever, and then you would have some rules to define them on the stream, and if you detect or rule fires, then you would instantiate a stream observation. Is that the idea?
It depends when do you, or it depends where and when you want to apply the annotations. For example, I'm considering I'm considering that it is not, at least the use case I have, it is not relevant to have annotations of this type stored for many vehicles, for example, because they are giving a lot of redundant information. But again, this is the use case I have.
Especially if the signal, especially if the signal value does not change over time, then you would have repeated observations with the same value or something like that.
Exactly. So what I know is that there are two options. You can, for example, decide to label individual observations this way, and then have some sort of RDF stream processing system that helps you to aggregate the data with some queries, and the outcome of these queries can be labeled with this ontology, for example, with the aggregations.
Okay. Yeah.
That's one option. A second option is if you don't have RDF data, but you have only the references to the vocabularies, and you are consuming the data, and you do the annotations directly on this. So this means that the RDF data will face this shape in the stream. So that in that sense, you don't rely directly on RDF stream processors, but you might have another system that is processing the data that is not using RDF. and the outcomes.
Okay.
The principle of the extension is to be able to express semantically the meaning of the sequences of the data, rather than only that there was an observation, but actually what the sequence of the observation means. But in the end, you will have both options. So the idea is to have both options. If you need this this low level definition of the observations, you can have it, but I don't see like a practical benefit of having the data in this way. Apart from like the granularity and the aggregations you can do, but in practice, if you have this, exactly, the volume is too big, especially for signals. That's just a consideration, but in the end you can have both. It depends on what you need. In my case, I'm focusing on reducing the space you use in practice, because the vehicle has constrained resources, and every single bit you send, it also costs like network, or the bandwidth you use costs. So one key aspect for me is reducing the volume when you are using a more expressive representation. I'm working on this model. Some queries, some implemented queries will follow in the next days or a couple of weeks, so we can have a second iteration over this if you find it interesting. So one example query, when I was testing the use of this IoT stream ontology, the benefit is that you can start mixing or integrating different signals. In this case, what is the minimum speed at which a dangerous event is detected in a particular section of the track? It could be a city, or could be a country, and so on. So you can split the queries into aspects that humans understand. So in this case, time windows of the specific location, you apply filter. Time windows of dangerous driving event, if you assuming that you have a model that is detecting this, and the property itself. So you can have queries that are combining this. So in the end, the benefit is that the logic of implementing this query becomes straightforward. The point where all of them connect in this example is the time windows that are sharing the same information. So the outcome in this case is, for that particular data set, was this value, for example. So this could be useful for some analysis on the streams. The point is that having these queries continuously running, instead of storing the data somewhere, you can have a system that is doing this aggregation constantly. So that is the focus of the model. That's it from my side. So what open points I identified is, for example, what regards to having domain and range. In the case of SOSA, for example, they don't use RDFS domain and range, but they use a schema.org domain includes and range includes to keep it flexible. But it's still to be decided, like if we should add this type of restrictions or not. Again, the preferred way of referring to specific units and quantity types, as I mentioned before, and dealing with events and stream observations with literals against a hierarchy of individuals. So what I presented in the model, you have a literal. So with a string, you can express any type of event, but if you have a controlled environment in application, for example, an ADA system that is talking about detected objects, there might be a subset of objects that are recognized or identified. So in that case, it makes sense to have a hierarchy of individuals instead of literals, especially if you want the people to use the model properly. So those are open points that I haven't found a proper answer yet to it. So yeah, as I said, I will be happy to discuss this topic further if someone wants more insights into this. Do you have any question or suggestion or?
Unfortunately, I have to step out now, but thanks again for the good presentation. Maybe we can discuss this in one of the next meetings.
Yes, indeed. Thank you for the slides, and I'll send you a pointer to presentation on what my company does with curve logging. So we sort of do this, the vehicle edge and embedded devices, so we minimize data that we need to offboard, not using ontologies, but just sort of similar as far as some of the advantages that you're mentioning. Although there's other ways that it can be used besides what you're doing. But what you're doing could be used in different ways besides that as well. But very interesting indeed.
One more question that I would have is like, this type of extensions, are they a good fit to have it in a country folder, for example, in the same VSSo specification, or should they be kept in other places?
So repeat the question, please. Sorry.
Yeah, what I said is like extensions like the one that I presented. Are they a good fit to be included in a country folder within the VSSo repository, or they should be hosted in another place?
That's a good question. So similar, because I'm thinking back to Covisa and how does VSS tools and other sort of formats that people in the community are contributing. It's like, you know, what's sort of official recommended, or what's sort of helpful things that people have come up with that others might want to leverage. This may be similar to that. So I think adjacent, we may want to have especially if we think there might be a bunch of extensions, so as not to clutter the VSSo repository too much, but have a VSSo extensions repository might be a good path. Just sort of thinking out loud, and I think that's something we can discuss and decide later. Daniel may have the other Daniel may have some thoughts on it. But since we're a couple minutes over, we shouldn't probably rush it at this moment.
Yeah, I think as well. I think we need a bit of stability in the VSSo, and then we can think, or we can add the extension. And I have to leave now as well. Kids have to go to bed now.
Thank you, everyone. Both Daniels and Felix, please send me, as I mentioned, copy of your slides. And thank you, everyone, for attending. After I get those slides, I'll make sure that they're online somewhere, and so we can link to them for the minutes. And I'll also make the recording available too.
Thanks. Bye-bye.
Thank you so much, guys. Bye-bye.
Thank you.
Bye-bye.
Bye.
Thank you, Joe.